We are looking at analytical geometry of grade 12 with the focus on circles. Firstly, we look at the definition of a circle. A circle is a set of all points which are equidistant from a common point. Let us look at this demonstration. We've got so many points around a point here in the middle. Now all these points, they've got equal distance from the point that is here in the middle. All these distances, they are equal. And the learners learned from the lower grade that the distance from the center of the circle to the circumference of the circle, it is called the radius of the circle. So this length here, it is the radius. Now, let us look at the definition of a circle when it is positioned on a set of axes. We say it is a set of all points with the distance r from the origin, and the x and y that represent the coordinate of the point on the set of axes. Now, let us look at the relations of circles with the center at the origin. A circle with a given point. Calculate the radius of the circle. Now let us consider this circle. So this circle has its center at the origin. The coordinate of the origin is 0 and 0. Now we need to find the length of the radius. Given the point on the circumference that this point is 2 and 2, all we need to do is we complete a right-angled triangle by dropping a perpendicular from that point. Now, at this point, the value of x is 2. So that means the horizontal distance here, it is 2 units, and the vertical distance here, it is also 2 units. And therefore, we can apply Pythagoras in a right-angled triangle to determine the length of the radius. So this will be r squared is equals to 2 squared plus 2 squared. That is 4 plus 4, and the answer is 8. So r squared is equals to 8. Therefore, r is equals to 2 root 2. That means each and every point that is found on the circumference of the circle here, it is 2 root 2 units away from the center of this point. Now, let us now look at the very same circle with the general point. So use the point P, that is the coordinate x and y, to calculate the radius of the circle. So we're going to do the same thing that was done in the previous circle. We drop a perpendicular at point P to complete a right angle triangle. Therefore, the horizontal distance here is x and the vertical distance is y. So, using Pythagoras, r squared is equals to x squared plus y squared. Now, this, it is the equation that defines every point on the circumference of the circle. And therefore, this is the equation of the circle that has its center at the origin on set of axes. Now, starting with circle number 1, we want to determine the equation of the circle. Now, the length from the origin to the circumference of the circle, this is the radius. What is the value of x at this point? Now, this circle has a tangent at this point with the equation of x is equals to 8. So the value of x at this point, it is 8. Now, this is the same as this horizontal distance from the point of origin right towards the circumference of the circle. So that means the radius of the circle is 8 units. Therefore, the equation will be x squared plus y squared is equals to 8 squared. So this is x squared plus y squared is equals to 64. Now, let us look at the next circle, circle number 2. So this is the radius of the circle. Now, we drop a perpendicular from the given point. The horizontal distance here is 2 units. So that is -2 since it's going in the negative direction. And the value of y is 3. So the length of the radius will be r squared is equals to -2 squared plus 3 squared. So this is -2 squared is 4, 3 squared is 9, and all this is 13. So r squared is equal to 13. Therefore, the equation of the circle is x squared plus y squared is equals to 13. So this is the equation of that circle. Now, when you look at the third circle, we're also given a point. Now, this point is in the third quadrant. We drop a perpendicular on the x-axis. So the horizontal length is 1 and the vertical length is 3. It is negative as it is going in the negative direction. So this will be r squared is equal to 1 squared plus -3 squared. And this is 1 plus 9, and that is 10. So r squared is equal to 10. Therefore, the equation of the circle will be x squared plus y squared is equals to 10. Now this, it is the equations of these circles. Draw the graphs of the following relations. So I'm going to look at the first relation, which is x squared plus y squared is equal to 2 squared. So this is the equation of the circle with the radius of 2. So this equation, in other words, is x squared plus y squared is equals to 4. So it has the radius of 2 units. Simply draw set of x's, and therefore you draw the circle with its center at the origin, and therefore indicate the radius. The length of this is 2 units. Now, the next question, we're given 3 minus x times 3 plus x. That is other factors of the difference of 2 squares. So in other words, we've got 9 minus x squared is equals to y squared. You take the negative x squared that side, you've got x squared plus y squared is equals to 9. So this is the equation of a circle with a radius of 3 units. So on the set of x's, a circle is drawn with its center at the origin, and then I demonstrate that it has the radius of 3 units. So this is how we work with the circle that has its center at the origin. Now, once this basic introduction is complete, learners need to do some exercise in order to show their understanding. They will find the equations of the circles that are placed here, and therefore they also have to draw the circles. Now, I'm just going to draw one circle. I'll take question 2b and use it to answer all those questions that follows. So, question 2b, they say 1 minus x times 1 plus x is equals to y squared. So to simplify this, we've got 1 minus x squared is equals to y squared. Therefore, the equation of this circle is x squared plus y squared is equals to 1. So this is the circle drawn at origin with its center at the origin and with a radius of 1. So that is the circle. Now, question 2a here, it says, is the relation a function? Well, this relation, it is not a function. Why is it not a function? Because it fails the vertical line test. It fails the vertical line test. What is the domain of the graph? So the domain, it is given by the values of x here. The radius of the circle is 1 unit. So this is 1 and that is -1. Therefore, the domain is x is the element of -1 to 1. The next question, they say write down the zeros of the relation. These are the x-intercepts. So that is x is equal to -1 or x is equal to 1. The range of the graph. So these are the values of y of the graph. So since the radius is 1 unit, so this is 1 and that is -1. So the range is y is the element of -1 to 1. So that is the range of the equation. Write down the equation of symmetry, at least 4. So remember that a circle, it is symmetrical by any line that passes through its center. Therefore, the y-axis, which is the line x is equal to 0, the x-axis, which is the line y is equal to 0, both are symmetrical lines of this graph. So that is x is equal to 0, y is equal to 0, the line y is equals to x, and the line y is equals to -x. All these lines, they are symmetrical lines of the circle that is drawn with its center at the origin. Now, let us look at the circle that is drawn with its center at a particular point. Now, let us look at the circle that is given here. They say, consider the circle below. The first question says, determine the radius of the circle. So, I'm looking at this circle. I can see the coordinate of this point is 5 and 4. So I'll call this point point P, and the central point I'll call it O. So we need to calculate the radius. So this is the radius. Now, I'm simply going to draw a vertical line through point P. That line is perpendicular to the x-axis. And I draw a horizontal line through point O, and that line, it is perpendicular to the y-axis. Now, these two lines, where they meet, they make a right angle triangle. The coordinate of this point, I'll call this point point B, it is 5 and 2. This line, the horizontal line, is the line y is equal to 2. This vertical line is the line x is equal to 5. This point comes from point P and the other one comes from point O, since the coordinate of O is 3 and 2. Now we need to find the length of the radius. Now, looking at the length BP, the length of BP is 4 minus 2, it is 2 units. The length OB is 5 minus 3, it is 2 units. Therefore, to find the radius, it will be r squared is equals to 2 squared plus 2 squared, and that is 4 plus 4 is 8. So the radius of this circle, it is therefore 2 root 2, since r squared is equals to 8. The next question, they say write down the equation of the circle. Now let us look at the position of this circle. So the circle got translated. The center point of the circle was at the origin, and it has been translated 3 units to the right and 2 units up. Now this simply means each and every point on the circle has been moved 3 units to the right and 3 units up. So the equation of this circle will therefore be, it is moving from r squared is equals to x squared plus y squared. Now we found that r squared is 8, so this will be 8 is equals to, we say the circle moved from the origin 3 units to the right, so that will be x minus 3 squared plus y minus 2 squared. So this will be the equation of this circle. Now, the last question says expand and simplify this equation. So I'm going to complete the expansion. It is 8 is equals to x minus 3 squared. It is x squared minus 6x plus 9 plus y minus 2 squared is y squared minus 4y plus 4. The simplified version of this equation of the circle, it is x squared minus 6x plus y squared minus 4y plus 5 is equals to 0. Now, let us consider the circle given on the right hand side. Looking at this circle, we're given 2 points. The first point is A. See, if the coordinate of point B is x and y, the coordinate of point B is x and y, the coordinate of A is A and B, and A, it is the center of this circle. So we do the same thing that we have done with the previous circle. Through point B, we draw a vertical line that is perpendicular to the x-axis. And through point A, we draw a horizontal line that is perpendicular to the y-axis. And our radius is the line AB. So this is our radius. For us to determine this radius, we need to find the horizontal line in this right angle triangle and find the vertical length in that. But what are the coordinates of this point? I'll call this point T. The value of x here is x, and the value of y is b, coming from point A. The horizontal distance will therefore be x minus a, and the vertical distance here will be y minus b. Therefore, if we're going to use Pythagoras, we simply say r squared is equals to x minus a squared plus y minus b squared. And this is the equation of the circle that has its center at a point. Let's look at example number 1. They say find the equation of the circle with the center -3 and 4 and with the radius of square root of 5. So we said the standard form for the equation of a circle centered at the point is r squared is equals to x minus a squared plus y minus b squared, where a and b are the coordinate of the center point. So this will be the square root of 5 squared is equals to x minus -3, that will be x plus 3 squared, and y minus 4 squared. Now the square root of 5 squared is 5, and the expansion of x plus 3 is x squared plus 6x plus 9, and y minus 4 squared is y squared minus 8y plus 16. So this is x squared plus y squared plus 6x minus 8y. 9 plus 16 is 25. Minus 5 is 20. So this is plus 20 is equal to 0. So this is the equation of this circle when it is simplified. Example number 2. Find the equation of the circle with the center 2 and -2, which passes through the point -4 and 5. So the equation of the circle has its center at 2 and -2. So this will be r squared is equals to x minus 2 squared plus y minus -2 is plus 2 squared. We need the radius of the circle. But we've got 2 points here. So we can find the distance between the center point and point B. So this is x minus 2 squared plus y plus 2 squared, which is just this equation. This is equals to r. Now r squared will be the distance between those 2 points. So that is 2 minus -4 is 2 plus 4 squared, and -2 minus 5, that is -7 squared. So this will be 2 plus 6, 4 is 6 squared is 36, plus 7 squared is 49. So we've got x minus 2 squared plus y plus 2 squared is equals to 36 plus 49. So that will be 85. So this is 85. The equation of this circle, it is x minus 2 squared plus y plus 2 squared is equals to 85. So this is the equation of the circle. Let's look at example 3. Find the equation of the circle which goes through the point D, E, and F. So the points we've got 3 and -1, the point 3 and -1. So the point is here, is 3 and -1. We've got the point 4 and 2, 4 and 2. That is the point E. This is the point D. And the point F is 1 and 3. So the point is 1 and 3. This is point F. So there is a circle that is passing through this point. So what do we know about this point? We are asked to find the center point. So I'm going to mark up a center point here and call it O. Now, it could be that it is on the x-axis, or it is above the x-axis, or it is below. But we will find that with the correct values. All we know that it is the central point, and the distance from this central point to F is equal to the distance from O to E, also from O to D. So the distance OF is equals to OE. So we're going to use the distance formula to solve this problem. I'll make the coordinate of the center point be x and y. So we then say the distance OF is equals to the distance OE. These are radii. These are radius of the circle. So the square of OE will also be equal to the square of OF. So I'm going to substitute those squares just so that I don't write the distance with the square root. OF will therefore be x minus 1 squared plus y minus 3 squared. This is equals to the distance OE. It is 4 minus x squared plus 2 minus y squared. We are going to expand and simplify this expression. So x minus 1 squared, this is x squared minus 2x plus 1 plus y squared minus 6y plus 9. This is equals to 16 minus 8x plus x squared plus 4 minus 4y plus y squared. Now, y squared minus y squared is 0. X squared minus x squared is 0. On the left hand side, we are left with negative 2x minus 6y plus 10 is equals to, on the right hand side, we've got negative 8x, negative 4y plus 20. Now we group like terms on one side of the equal sign. So this will therefore be 6x minus 2y, it is equals to 10. And this simplifies to 3x minus y is equals to 5. And we call this equation number 1. The distance OD and OE, those are also equal as they are radii of the circle. So OE is equals to OD. Now, therefore, OE squared is also equals to OD squared. So OE, it is x minus 4 squared plus y minus 2 squared. This is equals to x minus 3 squared plus y minus negative 1, that will be plus 1 squared. And we simplify the expression, is x squared minus 8x plus 16 plus y squared minus 4y plus 4. This is equals to x squared minus 6x plus 9 plus y squared plus 2y plus 1. And then we simplify the expression, x squared minus x squared is 0, y squared minus y squared is 0. On the left hand side, we are left with negative 8x minus 4y plus 20 is equals to negative 6x plus 2y plus 10. We bring like terms to one side of the equal sign. So we will have 2x plus 6y is equals to 10. We divide everything by 2, is x plus 3y is equals to 5. And you call this equation number 2. And we work these equations simultaneously. From equation number 1 or from equation number 2, I can make one of the variables the subject of the equation. In the first equation, we are looking at y as a coefficient of 1. In the second equation, we're looking at x as a equation of coefficient of 1. So I can say from equation number 2, this is our equation number 2, x is equals to 5 minus 3y. I call that equation number 3. And I take this equation and go substitute it in the equation number 1. So substitute equation number 3 in equation number 1. So this will be 3x, so that will be 3 times 5 minus 3y minus y is equals to 5. So this will be 15 minus 9y minus y is equals to 5. Negative 9y minus 1y, that is negative 10y. So I'll take it on the other side. I've got 10y is equals to 15 this side, that will give me 10. Therefore, y is equals to 1. So the value of y is 1. And therefore, I can take this and substitute in equation number 3. So x is equals to 5 minus 3 times 1. That is 5 minus 3 is 2. So the coordinate of the center point, the coordinate of O, it is 2 and 1. So those are the coordinates of the central point of the circle. Right. This only happens when we do not have the central point. We are only given 3 points through which the circle is passing through. Let's look at the next problem. They say determine the center and the radius of the following circle. So the circle is given in the standard form that is simplified. We therefore need to find the coordinate of center of the circle and the radius. That simply means that we need to change the standard form of the circle back to the original standard form of r squared is equals to x minus a squared plus y minus b squared. If we can change this equation, we'll be able to read the coordinate of the center point, and we'll also be able to read the radius of the circle. So we're going to complete the square on this expression and that expression. So this is the process of completing the square, we take half of the coefficient of x and square it. So this is x minus 3x plus half of negative 3, that is negative 3 over 2 squared. We add it and subtract it. So since we have the equation, I'll add it on both sides. So plus y squared plus 4y plus half of 4 is 2 squared. This is equal to negative 5, 1 over 4 plus negative 3 over 2 squared plus 2 squared. And therefore, this becomes the factors of those perfect square expressions. So this becomes x minus 3 over 2 squared plus y plus 2 squared. This is equals to negative 21 over 4 plus 9 over 4 plus 4. And we simply add those numbers is negative 21 over 4 plus 9 over 4 plus 4. That will give us 1. So in other words, the equation is x minus 3 over 2 squared plus y plus 2 squared. It is equals to 1. Therefore, the coordinate of the center point, I'll call that O. It is 3 over 2 and negative 2. And the radius is 1. In that way, we would have answered the question. Let us look at example number 5. So example number 5, it says find the equation of the circle through the point 3 and 2, 5 and negative 4 with its center on the line x minus y is equals to 1. So we're going to demonstrate this on a set of x's so we can have a picture and be able to solve this. So there is a circle that is passing through all these points in this format. Now we need to look for the central point. Now what else are we given? We are told that the central point of this circle lies on the line x minus y is equals to 1. So I'm just going to rewrite this equation in the standard form of y is equals to mx plus c. So this will be y is equals to x minus 1. So this is the other equation that they give us. Let's call this equation number 1. Now I'm going to sketch this equation on the Cartesian plane there. So the y-intercept is negative 1. So this is negative 1. And the x-intercept is 1. So the graph is passing through this point. So this is the straight line. Y is equals to x minus 1. Therefore, we are told that the center point of this circle lies on this straight line. So it lies somewhere along here. I'm going to make the central point here and call that point O. So what we know is that the distance from O to point P is equal to the distance from O to point Q. OP is equal to the length OQ. These are radii of the circle. So OP squared is equals to OQ squared. So this will be, I'll give the coordinate of the center x and y. So this will be x minus 3 squared plus y minus 2 squared. This is equals to x minus 5 squared plus y minus negative 4, that is plus 4 squared. And we simplify the expression. So this is x squared minus 6x plus 9 plus y squared minus 4y plus 4 is equals to x squared minus 10x plus 25 plus y squared plus 8y plus 16. Now x squared minus x squared is 0. Y squared minus y squared is 0. On the left hand side, we are left with negative 6x minus 4y plus 13. This is equals to negative 10x plus 8y plus that is 41. So that is the equation that we have on both sides. Now we put like terms on one side of the equal sign. So this will be 4x minus 12y. It is equals to 41 minus 13, that is 28. And there is a common factor of 4 on all of them. So we simply say this will be x minus 3y is equals to 7. And this is our equation 2. And then, since from our equation we knew that y is equals to x minus 1, we can simply substitute y in this equation. This is x minus 3 into x minus 1 is equals to 7. So this is x minus 3x plus 3 is equals to 7. Now x minus 3x, that gives us negative 2x is equals to 3 on the other side. 7 minus 3, it is 4. Therefore, x is equals to negative 2. Therefore, we substitute the value of x in the equation. Y is equals to negative 2, negative 1, that is negative 3. Therefore, the coordinate of center is negative 2 and negative 3. So this radius will be r squared is equals to 5 minus negative 2 squared plus negative 4 minus negative 3 squared. So this will be 5 plus 2 squared is 7 squared is 49 plus negative 4 plus 3 is 1 squared is 1, that is 50. Therefore, the circle will be x plus 2 squared plus y plus 3 squared is equals to 50. So that will be the equation of the circle. With all the work that has been done, it is now the time for the learners to exercise, to demonstrate their understanding. So these were several questions that I specifically chose for the learners to work through from the Mind Action textbook. In this case, we are focusing on the equations of the tangent to the circle at the point on the circle. So let us look at the first example. They say find the equation of the tangent which touches the circle that x plus 2 squared plus y plus 3 squared is equal to 10 at point 1 and negative 2. So I just demonstrated the circle on the set of axes and the important point. From the equation, we can see that the coordinate of center is negative 2 and negative 3, and we are given the point of contact as 1 and negative 2. So here is the point of contact with the tangent. The first example says find the equation of the tangent which touches the circle at the point 1 and negative 2. So, like I always say, try and draw the sketch of this information so that you will be able to have a picture. So the circle has its center at negative 2 and negative 3, and therefore it has a tangent at point 1 and negative 2. So find the equation of the tangent line. We have the center point and we have the point of contact. Now, one of the grade 11 Euclidean geometry theorem says the tangent and the radius of the circle, they are perpendicular at the point of contact. So that is the other line that I'm going to demonstrate here. The radius and the tangent at the point of contact, they are perpendicular. So the other concept that we learned in grade 10 is that the product of gradient of perpendicular lines is equals to -1. Therefore, we're simply going to find the gradient of the radius, and therefore we'll be able to find the gradient of the tangent. So the gradient of the radius, this will be given by this formula. So the gradient of the radius is equals to change in y over change in x. So that is -2 minus -3. That will be -2 plus 3 divided by 1 minus -2. So this is equals to 1 over 3. So the gradient of the radius is 1 over 3. Now, if the gradient of the radius is 1 over 3, therefore the gradient of the tangent is equals to -3. Therefore, we can now find the equation of the straight line. Y is equals to mx plus c. We have the gradient of the tangent is y is equals to -3x plus c. Now, the point of contact, it is the point on the tangent and the point on the graph on the circle. So we're going to take that point and substitute it in this equation. So this is -2 is equals to -3 into 1 plus c. Therefore, c is equals to 1. Now, we can come and replace it there. Then the equation of the tangent is -3x plus 1. So this is the equation of the tangent to the circle. You see, find the equation of the tangent to the circle. We are given a circle in that simplified standard form, and we are given the point of contact. So the first thing that we would need to do is we need to complete the square on this equation and find the coordinate of the center. So this is the equation. It is x squared minus 2x, half of -2, that is -1 squared, plus y squared plus 4y, half of 4, that is 2 squared, is equals to 5, plus -1 squared is 1, 2 squared is 4. So this will then be x minus 1 squared plus y plus 2 squared is equals to 10. So this is the equation of the circle in this format. Now we know the coordinate of the center point is 1 and -2. So we need to find the gradient of the radius, the point from the center to the point of contact, which is -2 and -1. So that will be the radius, the gradient of the radius is equals to change in y over change in x. It is equals to change in y over change in x, which is -1 minus -2, that will be plus 2, divided by -2 minus -1. So this is 1 over -3. That is the gradient of the radius. Therefore, the gradient of the tangent is equals to 3. Now, the point of contact is -2 and 1. So this is y is equals to mx plus c. We substitute, that is 3x plus c. And we take the point of contact, we plug it in. As -1 is equals to 3 into -2 plus c. And therefore, c is equals to 5. So the value of c is 5, because this is -6 and it will change the sign. Therefore, we can now replace it in the equation is y is equals to 3x plus 5. So this, it is the equation of the tangent to the circle at the point -2 and -1. Now, let's go and look at the next example. The last example says, example 3, find the equation of the Find the equation of a circle with center 2 and 3, which touches the x-axis. Now, the demonstration here is that if you drop the perpendicular through a line drawn through the center perpendicular to the x-axis, the equation of this line is x is equals to 2. It's passing through that central point. The value of y here is 3. So that means from this point here all the way to the central point is 3 units. Therefore, this makes the radius of this circle 3. Now, we need to find the equation of this circle. We have the center point. We have the radius. So this will simply be r squared is equals to x minus a squared plus y minus b squared. So this is 3 squared is equals to x minus 2 squared plus y minus 3. And therefore this is x minus 2 squared plus y minus 3 squared is equals to 9. So that is the equation of the circle. Now, one last thing that we need to look at, it is the concept of intersection of circles. Two circles can intersect one another at 2 points, or they may not intersect at all. So let us look at that scenario. If the distance between the centers of the two circles is less than the sum of the radii, then the circles intersect one another twice. So let's look at the demonstration. Here are two circles intersecting at each other. Now, what does this mean in terms of what we just read? We say if the distance between the centers of the circle, the distance between the point A and point B, we say if the distance between the centers of the two circles is less than the sum of the radius, if the distance between the centers of the two circles is less than the sum of the radii, then the circles intersect one another twice. So that means the distance between the center point, which is the one that I marked, it is less than the sum of this radius, the radius of the smaller circle. So this is the radius of the bigger circle. So I'll mark it the radius of the bigger circle and the radius of the smaller circle. So if the distance between AB, it is less than the sum of the radius of the bigger circle plus the radius of the smaller circle, therefore these circles, they intersect twice. So let's go and find out that. So the distance AB is equals to 3 squared plus negative 2 squared. That is 9 plus 4, and that is 13. That is the square root of 13. Now, what is the sum of the bigger circle? The radius of the bigger circle plus the radius of the smaller circle. That is 3 plus. Now, what is square root of 13? Square root of 13, it approximates to 3.6. Therefore, in this case, the distance of AB is smaller than the sum of the radius of the two circles. Therefore, these circles, they intersect twice. Circles intersecting at one point, meaning they are tangential. If the distance between the centers of the two circles is equal to the sum of the radii, then the circles intersect one another once, or they are tangential. So we are saying, let's look at the picture. If the distance between the centers of this circle, the distance AC, if the distance AC is equals to the sum of the radius of the bigger circle plus the radius of the smaller circle. Therefore, that means these circles are tangential. Now, from this, we see the coordinate of C, it is 7 and 0, and the coordinate of A is 0 and 0. Therefore, that means the distance AC, basically the distance AC is equal to 7 units. But what is the radius of the smaller circle? From there, r squared is 9, therefore the radius of the smaller circle is 3, and therefore r squared is 16 for a bigger circle, then the radius is 4. And 4 plus 3 is 7. So the radius of the bigger circle plus the radius of the smaller circle is equal to 7. Therefore, the distance of the centers AC is equal to the sum of the radius. Therefore, these circles, they touch each other at one point. They are tangential. Now, one last aspect of this circles touching or not touching, we say if the distance between the centers of the two circles is greater than the sum of the radii, then the circles do not intersect one another. So let's look at that. If the distance between the centers A and D is bigger than the sum of the radius, therefore these two circles, they don't intersect. Now from here, the radius of the circle that is centered at the origin is 3, since r squared is 9. So this is 3, and the radius of the smaller circle is 2. Now, what is the distance between the point AD? So the distance AD is therefore 6 squared plus 1 squared. So that is 36 plus 1 is 37. Now, the square root of 37. Then let's go and look at the sum of the radius. The radius of this bigger circle plus the radius of the smaller circle, that is 3 plus 2. This is equals to 5. So the distance between the 2 points, it is bigger than the sum of the radius. Therefore, these two circles don't intersect. So we say the distance AD is greater than the sum of the radii. Therefore, these circles, they do not intersect.